Good afternoon. Welcome to
FamilyMath number 825.
FamilyMath825. Still have the same problem where everything in our camera is red, but it didn't come out that way the other day. Okay, so this is a problem our friend Alexander Bogomolny posted, and this is a problem I actually knew ahead of time. It is from the 1982 American High School Mathematics exam, and it's actually a pretty neat problem. The figure below is a map of part of a city. Small rectangles are blocks, and the spaces in between are streets. Each morning a student walks from intersection A to intersection B, always walking along the streets shown, always going east or south. For variety, at each intersection where he has a choice, he chooses with probability 1/2, independent of all other choices, whether to go east or south. And the question is, find the probability that on any given morning he walks through intersection C.
Alright.
Okay, so what I'm going to do, I'm going to just zoom in on the street, I think anyway. And why don't you tell me how you think you would solve this problem?
So how I would go about solving this is, since the probability is equal to go either way, I'm just going to count the number of ways to get from A to B and from A to C, and then do whatever when we get to C over when we get to B.
Okay.
So we know we've got one way to go all down and one way to go all across like that.
Okay.
Then we got 2 ways to get to here, 3, 4, and 5, and then 3, 6, 10, 15, and then 4, 10, so C is 20, and then B is 35.
Okay.
So it looks like we're going to have 20 and 35 or 4 7s.
Okay. Interesting. This is not the correct answer, but shows something actually pretty interesting. What is 20 out of 35?
So it's the number of ways to get to C out of the number of ways to get to B.
That's right. That is exactly what 20 over 35 is. It's the number of total ways to get to B that pass through C. Okay. But this asked about probability instead. So what do you think is wrong? Just having me tell you that this is not the correct answer for the probability, what do you think may have gone wrong with this analysis?
Well, I know that when you get to C, there's no way to not go to B. When you get to C, you have to go to B.
Right.
I'm going to get to this other point, you have to go to B.
Yep.
But it looks like you're more likely to get to C than you are to get to this other point.
Okay. Why do you think that?
Well, because there's more ways to do it.
There are more ways to do it, yep. Interesting. Okay, well, for this to be the right probability, all these paths would have to have the same probability. So 35 different paths, all with the same probability, 20 passing through C.
But some aren't going to be the same probability.
Some aren't going to be the same probability. And do you have any intuitive sense for why?
Well, because it's not as likely that you'll get 4 souths in a row.
Or
3 easts in a row.
Well, it's close. It's close. It has, can I see the pen? It has to do with the fact that the probabilities at places like this, and here, are not the same as the probabilities when you leave here. So when you leave here, you can go one way or the other way. When you leave here, you only have one way to go. So the probability of getting here, from here, is half the time. Right? But the probability of getting here from up here is 100% of the time. So we got to follow not the paths, but we got to follow the probabilities. So we'll print out a second sheet and we'll follow the probabilities and see if we can calculate that.